Hello and welcome. Today you are going to solve the problems from exercise 20b. The perimeter of a rectangle is L plus B plus L plus B. That is the length of all the sides of the rectangle, and that become twice L plus B, length plus breadth. And area of the rectangle is length multiplied by breadth square units. And the diagonal D is equal to root over L square plus B square, because the diagonals makes it two triangles and these two triangles are right angle triangle. So according to the Pythagoras theorem, L square plus B square is equal to D square. D is the hypotenuse for the triangle and D is also the diagonal of the rectangle. And in case of a square of side A, perimeter is sum of the sides of the square, and that become 4A because all sides are equal. Area of a square is length multiplied by breadth, and length and breadth are equal, so A multiplied by A, it become A square. And diagonals of a square are also equal, and since the sides are equal, it become root over A square plus A square. So this is equal to root over 2 multiplied by A, this mass of units. Now let us solve first question number 2. The perimeter of a rectangle is 46 meter and its length is 15 meter. Find its breadth and area and also the diagonal. Perimeter is given. Perimeter P is equal to twice L plus P. So perimeter is given 46 meter is equal to twice L. L is equal to 15 plus B is not given. Breadth we have to find out, and if you solve this, you will get this is equal to 15 plus B is equal to 46 meter divided by 2, that is equal to 23 meters, and therefore B is equal to 23 meters minus 15 meters, that is equal to 8 meters. So breadth B is equal to 8 meters. So this is number 1. Then number 2 is find the area of the rectangle. Area is equal to L multiplied by B. So L is equal to 15 meters multiplied by B is 8 meters, and that is equal to 120 meter square. Find the diagonal of the rectangle. So diagonal is equal to root over L square plus B square, and that is equal to root over L is 15 square plus B is equal to 8 meter square. So that is equal to 15 square is equal to 225 plus 64 meter square, and that is equal to root over 289 meter square, and if you find the square root, you will get 17 meter. So diagonal of the rectangle is 17 meters. Question number 3. The diagonal of a rectangle is 34 centimeter. If its breadth is 16 centimeter, find its length and the area. So number 1, diagonal is given 34 centimeter, that is equal to L square plus B square. What is L and B? Diagonal is 34 meter and breadth is 16 centimeter. So we have to find L. So diagonal is equal to 34 is equal to root over L square plus B is equal to 16 centimeter square. So if we square on both the sides, is equal to L square plus 16 square is equal to 256. So L square is equal to 34 square is equal to 1156 minus 256, and that is equal to 900. So L is equal to root over 900, and this is equal to 30 centimeter. So length of the rectangle is 30 centimeter. number 2, we have to find the area of the rectangle. So area is equal to L into B, 30 meters multiplied by B. Length is 30 centimeter multiplied by 16 centimeter, and that is equal to 480 centimeters square. Question number 4. The area of a small rectangular plot is 84 meters square. If the difference between its length and the breadth is 5 meter, find its perimeter. So area is given. Length into breadth is equal to area. L into B is equal to 84 meter square. From this we get L is equal to 84 divided by B meter. So this is equation number 1. The difference between length and the breadth is 5 meter. So L minus B difference is equal to 5 meters. If we put the value of L here, that is 84 divided by B minus B is equal to 5. So B is LCM. 84 minus B square is equal to 5, and therefore 84 minus B square is equal to 5B. So if you rearrange this, it will be B square plus 5B minus 84 is equal to 0. So if you do the factorization here, 84, 4 21s are 84, again 3 7s are 27, so 12 into 7, and 12 minus 7 is equal to 5. So what we do, B square plus 12B minus 7B, so 12 minus 7 remain 5B, minus 84 is equal to 0. So B is common. B plus 12 minus 7 is common, and B plus 12 is equal to 0. So B plus 12 is common, and then this is B minus 7 is equal to 0. So either B plus 12 equal to 0 or B minus 7 is equal to 0. So from this we will get B is equal to minus 12, which we cannot consider, and B is equal to 7. So we'll take B is equal to 7. So B is the breadth of the rectangle. Therefore breadth B is equal to 7 meters. Therefore length L is equal to 84 divided by 7 meter, 12 meters. Now you have to find the perimeter. Perimeter of the rectangle is equal to twice L plus B, and that is equal to twice L is equal to 12 meters plus B is equal to 7 meters. So this much meters. So 2 multiplied by 19 meters, and that is equal to 38 meters. Now question number 5. The perimeter of a square is 36 centimeter. Find its area. So this is a square of perimeter 36 centimeter. Perimeter of a square is equal to 4 multiplied by A. So perimeter is given. This is 36 centimeter. That is equal to 4 into A. Therefore A, the side of the square, is 36 centimeter divided by 4, and that is equal to 9 centimeter. So the side of the square is 9 centimeter. Therefore area of the square is equal to A square, side square, is equal to 9 centimeter square. That is equal to 81 centimeter square. Question number 6. Find the perimeter of a square whose area is 1.69 meters square. So this is also a square, and here the area is given. You see A square is the area of a square, and that is equal to 1.69 meters square as given in the question. Therefore A is equal to root over 1.69 meters square, and if you find the square root of 1.69, then it will be equal to 1.3. So meter square become meter. Side of the square is 1.3 meter. Now you have to find out the perimeter. So perimeter is equal to 4a. So 4 multiplied by 1.3 meter, and this is equal to 5.2 meters. Question number 8. The diagonal of a square is 15 meter. Find the length of its one side and perimeter. So this is the square and the diagonal is 15 meter. Diagonal D is 15 meter. So what is the diagonal? Diagonal is root over 2a is equal to diagonal. So therefore root over 2a is equal to, diagonal is given 15 meter. Therefore a is equal to 15 divided by root over 2 meters. So now we have to find out the perimeter. So perimeter P is equal to 4a. Therefore 4 multiplied by a is equal to 15 divided by root over 2 meters. And we can write 4 is equal to 2 into root 2 into root 2 into 15 divided by 2 meters, not 2, root over 2. So root over 2 get cancelled. So it will become 30 root 2 meters. This is the perimeter of the square. Question number 10. The length of a rectangle is 16 centimeter and its perimeter is equal to the perimeter of a square with side 12.5 centimeter. Find the area of the rectangle. So this is the rectangle and this is the square. For rectangle, one side we know, and for the square we know the side. That means all the sides we know. So find the area of the triangle. Perimeters are given, same perimeter. So first we'll find perimeter of a square is equal to 4a, and that is equal to 4 multiplied by 12.5 centimeter. So this is equal to 50 centimeter. This is the perimeter of the square. Again, the perimeter of a rectangle is equal to twice L plus B, and here 2 multiplied by L is given, that is equal to 16 plus B, and it is also in centimeter. According to the question, the perimeter of the rectangle is equal to the perimeter of the square. Therefore, P rectangle, perimeter of the rectangle is equal to perimeter of the square. This is given. So let us write 2 into 16 plus B is equal to 50. So from this is 32 plus twice B is equal to 50, and here twice B is equal to 50 minus 32, that is equal to 18. Therefore P is equal to 9. So we got breadth B is equal to 9 centimeter. So we have to find the area of the rectangle. So now area of the rectangle, area is equal to L multiplied by B. So L is equal to given, that is 16 centimeter, and breadth is 9 centimeter, just we have found out. So 16 into 9, it become 144 centimeter square. So this is the area of the rectangle. Question number 11. The perimeter of a square is numerically equal to its area. Find its area. As I have mentioned in the previous videos also, perimeter cannot be equal to area. Only the numerical part can be equal, because the unit of perimeter is say meter, then unit of area will be meter square. So perimeter of the square is equal to area of the square. So suppose A is the side as given in the diagram. So perimeter of the square is 4A, that is equal to area of the square is A square. So you solve this, A square minus 4A is equal to 0. Therefore take A common, A minus 4 is equal to 0. So either a equal to 0 or a minus 4 equal to 0. So a cannot be equal to 0 because we are considering the side of a square only. So a is equal to 4. Therefore find the area. So area of the square equal to a square, and that is equal to 4 square, and that is equal to 16 square units. Question number 12. Each side of a rectangle is doubled. Find the ratio between perimeter of the original rectangle and the resulting rectangle. Also, the ratio between area of the original rectangle and the resulting rectangle. So, the first rectangle is, say, rectangle 1 with length L and breadth B. Now, if the sides of the rectangle is doubled, then after doubling the sides, we call this rectangle rectangle 2. Now length become twice L and breadth become twice B. So we can solve it like this. Let P1 and P2 are the perimeters of rectangle 1 and rectangle 2 respectively. Then you see P1 divided by P2, perimeter of rectangle 1 divided by perimeter of rectangle 2 is equal to, so what is P1? This is twice L plus B divided by, for rectangle 2, twice length is twice L plus breadth is also twice B. So 2 is cancelled, and this is equal to L plus B divided by 2 common L plus B, then L plus B common. So this is equal to 1 by 2. So P1 is 2, P2 is equal to 1 is to 2. This is number 1. Perimeter of the original rectangle and the resulting rectangle ratios. So number 2 is find the area, that means ratio between the area of original rectangle and the resulting rectangle. So here we can consider, say, A1 and A2 are the areas of the rectangle 1 and rectangle 2 respectively. So A1 divided by A2 is equal to area of the first rectangle, rectangle 1, is equal to L multiplied by B, and area of the rectangle 2 is twice L multiplied by twice B. So that is equal to L into B divided by 4 into L into B. So B, L get cancelled. This is equal to 1 divided by 4. Therefore, A1 is to A2 is equal to 1 is to 4. The ratio between area of original rectangle, that means rectangle 1 and rectangle 2, is 1 is to 4. Question number 13. In each of the following cases, what is the case? This is the case 1. ABCD is a square and PQRS is a rectangle. Find in case 1 the area of the shaded portion. That means within PQRS, this rectangle, there is a square, and outside the square, this is the shaded area. So how we can do, say this is number 1, that means case 1. Say area of the rectangle is equal to L into B, that is equal to 3.2. It is given in meters, I think. 3.2 multiplied by 1.8 meters, and that is equal to 5.76 meters square. Then area of the square is equal to A square, that is A is equal to side of the square is 1.4 meter, so 1.4 meter square, and that is equal to 1.96 meter square. Now what is the shaded area? The shaded area is area of the rectangle minus area of the square. So area of shaded portion is equal to area of the rectangle minus area of the square, and that is equal to 5.76 minus 1.96 meter square equal to 3.8 meter square. This is number 1. And what is the case 2? In case 2, ABCD is a square, and inside the square there is a rectangle PQRS. So these are the shaded area. So same way, area of the rectangle is equal to L into B, that is equal to 4.8 centimeter multiplied by 3.6 centimeter length and breadth, and that is equal to 17.28 centimeter square area of the rectangle. And again, area of the square is equal to a square. The side of the square is 6, so 6 centimeter square, that is equal to 36 centimeter square. So area of the shaded portion is equal to area of the square minus area of the rectangle, and that is equal to 36 minus 17.28 centimeter square. So this is equal to 18.72 centimeter square. Question number 15. A path of uniform width 2.5 meter runs around the inside of a rectangular field of dimension 30 meter by 27 meter. Find the area of the part. So suppose PQRS is the rectangular field, and you have to make a part inside this, and the width of the part is 2.5 meter. So these are all 2.5 meters, and we have to find the area of the part. So how we can do? If you have to make a part around the field inside the rectangular field, then this is the part. This will be the part, and width of this part is 2.5 meter. This is also 2.5 meters, and this is also 2.5 meters, and this is also 2.5 meters. So the length of this small rectangle become 25, because 30 minus 2.5 meter on both sides, so it become 25 meters, and width is 27 minus 2.5 minus 2.5, so this is 22 meters. So area of the bigger rectangle, area PQRS, is equal to length is equal to L into B, that is equal to 30 meter multiplied by 27 meter, and that is equal to 810 meter square. Then area ABCD, rectangle ABCD, is equal to L into B again, and this time length is 25 meters and width is 22 meters, and that is equal to 550 meter square. So area of the part is equal to area PQRS minus area ABCD. So that is equal to 810 minus 550 meter square. So this will be equal to 260 meter square. Question number 16. The length of a hall is 18 meter and width is 13.5 meters. Find the least number of square tiles, each of side 20 centimeter, required to cover the floor of the hall. Number 1, without leaving any margin, and number 2, leaving a margin of width 1.5 meter all around, and in each case find the cost of the tiles required at the rate of rupees 6 per tile. So suppose this is the rectangular hall of 18 meter length and 13.5 meter width. So first we will find area of the hall is equal to L into B, that is 18 meter multiplied by 13.5 meters, and that is equal to 243 meter square. Now area of one tile we have to find out, because the square tile will be used like this one. Say this is the square tile and size of the tile is 2.5 centimeter by 2.5 centimeter. So what is the area of one tile? Area of one tile is equal to 25 centimeter multiplied by 25 centimeter. That is equal to, if we convert it to meter, then it is 0.25 meter multiplied by 0.25 meter, and that is equal to 0.0625 meter square. So if we do the tiling in the hall, then hall will be covered with tiles without any margin. That means whole area of the hall will be covered with the tiles. So how many tiles required? So that we can find out, number of tiles required is equal to total area divided by area of one tile, and total area of the hall is 243 meters square divided by 0.0625 meter square area of one tile, and that is equal to, if you do this sum, then this will be 3880. So 3880 tiles are required without leaving any margin. Number one, we can find the cost of tiling. So for that, cost of tiles is equal to rupees 6 per tile. Therefore, total cost is equal to rupees 6 multiplied by number of tiles, 3880. So this is equal to rupees, total cost is 23,280 without leaving any margin. Now if we leave a margin of 1.5 meter all around, so this is the hall and we have to fit the tiles like this by leaving a margin of 1.5 meter all around. So this is the margin, that is 1.5 meter all around. This is 1.5 meter, and this is also 1.5 meter, and here also this is 1.5 meter. The area of the tiling is 18 meter minus 1.5 meter in the left and 1.5 meter in the right. So this will be 18 minus 3, so this is 15 meters. So total length of tiling will be 15 meters. And what will be the width of tiling? That is equal to 13.5 minus 1.5 minus 1.5 at the top and minus 1.5 at the bottom, and that is equal to 13.5 minus 3, so 10.5 meters. So area of tiling required is 15 meter by 10.5 meters. Area of floor for tiling is equal to L into B, length into breadth, and that is equal to, now we need 15 meters length and 10.5 meters width, and that is equal to 157.5 meters square. 157.5 meter square. Area of one tile that we have found out, that is equal to 0.0625 meter square. So in this case, number of tiles required is equal to area of the tiling 157.5 meter square divided by 0.0625 meter square, and that is equal to, you can also express it in the fraction, of course. Number of tiles required is equal to 2520. So what is the cost? The cost of tiling is equal to, this is rupees 6 again, and area, a number of tiles is 2520, so that is equal to rupees 15,120. So in this 25 centimeters, you can do it like this: 25 divided by 100 meter. So you can use the fraction 1 by 4 also. I have expressed it in decimal, but you can express it in fraction also. Then area will be 1 by 4 multiplied by 1 by 4, that is equal to 1 by 16, 1 divided by 16. And 1 divided by 16 is 0.0625. So I think you will be more comfortable with fraction only, then you can use this in the fraction also. 25 centimeter equal to 1 divided by 4 meters multiplied by 1 divided by 4 meter, that will be divided equal to 1 by 16 meter square. Question number 17. A rectangular field is 30 meter length and 22 meter in width. Two mutually perpendicular rows of 2.5 meter wide are drawn inside the field so that one road is parallel to the length of the field and other road is parallel to the width of the field. Calculate the area of the crossroads. So this is the field, length is 30 meter and width is 20 meter. So inside this field we have to construct two roads, and the horizontal road is parallel to the length of the rectangle and the vertical road is parallel to the vertical side of the rectangle. So these are the two roads, and we have to calculate the area of these crossroad. What we can do, we can find the area of the horizontal road, then again area of the vertical road. You can see from the diagram, this area is common in both the cases, then this area is counted twice. So that is why we have to deduct this area from the total area. This area we have to deduct. Area of horizontal road is equal to length into breadth, and length is length of the rectangle, that is equal to 30 meter, and width is the width of the road, and that is equal to 2.5 meter. So that is equal to 660 meters square, area of the horizontal road. Now we will find out the area of this road, vertical road, is equal to again length into breadth. The length of the road is the length of the width. That means this time it is 22 meters, and breadth is width of the road, and that is equal to 2.5 meters, and this is equal to 55 meters square. Sorry, this is not 660, this is actually 75 meters square. So what is the common area of the road? Is this area or this area, which is counted twice, and that is equal to 2.5 meter multiplied by 2.5 meters, and that is equal to 6.25 meters square. Now what is the actual area of the road, crossroads? That is equal to, say, area of crossroad is equal to area 75 meters square plus 55 meters square, and this area is counted twice, so we have to deduct it once, that is 6.25 meter square. And if we do this, then you will find it to be 123.75 meters square, area of the crossroad. Question number 18. The length and breadth of a rectangular field are in the ratio 5:4 and its area is 3,380 meters squared. Find the cost of fencing it at the rate of rupees 75 per meter. Okay, let length of the rectangular field L is equal to 5x meter and breadth of the rectangular field is 4x meter. Therefore, area is equal to length 5x multiplied by breadth 4x, and that is given, that is equal to 3,380 meter square. So this is 20x squared is equal to 3,380, and therefore x square is equal to 169. How will get 169? 3380 divided by 20 is equal to 169. Therefore, x is equal to root over 169. If you find the square root, then this is equal to 13, because 13 square is equal to 169. So if x equal to 13, so L is equal to 5x meter, that is equal to 5 multiplied by 13 meters, and that is equal to 65 meter. Again, breadth of the rectangular field is 4x meters, and that is equal to 4 into 13 meters, and that is equal to 52 meters. We get length and breadth of the rectangular field. Now we have to give a fencing around this. That means we have to find out the perimeter. So we find the perimeter of the rectangular field. P is equal to twice L plus B, and that is equal to twice L is equal to 65 plus B is equal to 52 meter, that is equal to 2 multiplied by 117 meter, and that is equal to 234 meters. So for 234 meters we have to give the fencing. Cost of fencing is equal to rupees 75 per meter. That means you can write cost of 1 meter fencing is equal to rupees 75. Therefore, cost of 234 meter fencing is equal to rupees 75 multiplied by 234, and that is equal to rupees 17,550. Cost of fencing around the boundary of the rectangular field. Question number 19. The length and breadth of a conference hall are in the ratio 7:4 and its perimeter is 110 meter. Find the area of the floor of the hall. First, let us find the area of the floor. So L is to B, length is to breadth is equal to 7:4 as per question. The length and the breadth of the conference hall are in the ratio 7:4. L divided by B in fraction form, this is 7/4. So from this, L is equal to 7 divided by 4B. So this is equation number 1. Now again, perimeter is given. Perimeter is equal to twice L plus B, and perimeter is given 110 meter is equal to twice L. In place of L, we put 7 divided by 4B, and this is plus B. So you can simplify this. 110 is equal to 2 into 4 is the LCM, 7B plus 4B. So 7B plus 4B is 11B is equal to 110 multiplied by 2. Therefore, B is equal to 110 multiplied by 2 divided by 11, and that is equal to 20. So this is 20 meter. Breadth of the hall is 20 meter. So length L is equal to 7 divided by 4 into B, and that is equal to 7 divided by 4 into B is 20 meter, and that is equal to 4 5s are 20, and this is 35 meter. So length is 35 meter. So number 1, area of the hull is equal to length into breadth, and that is length is 35 meter and breadth is 20 meter, so that is equal to 700 meters square. Now question number 2, number of tiles each a rectangle of size 25 by 20 centimeter required for flooring of the hull. So let us do question number 2 now. We have to do the flooring by tiles. This time it is rectangular tile of size 25 centimeter by 20 centimeter size. So first let us find the area of the tile. So I have to remove these things. So this is number 2. First you find out area of one tile is equal to 25 centimeter multiplied by 20 centimeter. So this time we'll do it in fraction. 25 centimeter is 1 by 4 meter, because 25 divided by 100, that become 1 by 4, multiplied by 20 centimeter divided by 100, that is 1 divided by 5 meter. So area is 1 divided by 20 meter square. This is the area of one tile. Now number of tiles required is equal to total area of the floor, that is equal to 700 meter square divided by 1 divided by 20 meter square, and that is equal to 14,000 tiles required for tiling the floor. Okay, if that is so, now we can find out question number 3. The cost of the tiles at the rate of rupees 1400 per 100 tiles. Okay, cost of one tile is equal to rupees 1400 divided by 100, because this cost is 1400 per 100 tiles. So for one tile it will be rupees 14 only. So total cost will be equal to rupees 14 multiplied by number of tiles, that is equal to 14,000 tiles required for flooring, and that is equal to rupees 1,96,000 cost of tiling the floor. So this is all about exercise 20B. So in the next video we'll solve all the exercises from chapter 18C on areas of trapezium, parallelogram and rhombus. Thank you for watching. Please do subscribe to the channel to encourage me to make more videos on these topics.